In this video, we are going to review a very important concept in Algebra 1, 2, Pre-Calc, Calc, so on. And that topic is factoring. Now, when you're factoring, there's several methods that you want to use or that you want to know how to use. And the order in which you try them does matter, so we're going to go through it one by one. Now, the first method that you want to try, or the first thing that you want to look for, is to see if there's a greatest common factor that you can pull out of all the terms. You don't want to pull it out of just 2 or 3 terms. You want to be able to pull it out of every single term. So in this first example, there's 4 terms, and I want to look to see if there's a factor that is common to all 4 of them. In this case, usually what I do is I just look at the numbers first. In that case, 3 would be the greatest common factor. And then I look at the variables. And because not every single term has a variable, I can't factor out a variable. So I would just factor out a 3, which means I would be left with 2x cubed minus 9x squared plus 10x plus 4. Now let's look at a different example. Let's say I had 4x to the 4th minus 12x to the 2nd plus 44x. We'll leave it like that. Okay, now if I look at these terms, is there a factor that's common to all of them? The answer is yes. The GCF in this case would be a 4x. And what we're left with then is x cubed minus 3x plus 11. Now, anytime you're factoring, you can always check your work by multiplying out the polynomial. So if I was to redistribute 4x back into the parentheses, would I get what I had originally? That's a way to check your work. So 4x times x cubed does give us 4x to the 4th. 4x times negative 3x does give us negative 12x squared, and 4x times 11 does give us 44x. So that's how I know I did it correctly. So that's the first thing you want to look for. Now, if there is no greatest common factor to be taken out, then we move on to the second method, which is the perfect squares method. Now, this method you use when your first and last terms are perfect squares, or I should say you want to try this method when your first and last terms are perfect squares. Keeping in mind that currently we're looking at polynomials that are in standard form, so something like that. And basically all you want to do is take the square root of those perfect squares, and that will be the polynomial in factored form. So for this first one, 64x squared is a perfect square. 1 is also a perfect square. So the square root of 64x squared is 8x. So that's going to be the first term in both parentheses. And then the square root of 1 is just 1. So that's the the second term in both parentheses. Again, to confirm that we did that correctly, we would just multiply this out or FOIL it. 8x times 8x is 64x squared. Outer, inner, if you're doing FOIL, plus 1. And then when we combine like terms, we do, in fact, get 16x. All right. Moving on to another example. Same idea. First and last term are perfect squares. So the first term of the factored form is going to be the square root of 9x to the 4th, which would be 3x squared. And then the square root of 100 is just 10. And in this case, because the middle term is a negative, I know my outer inner, when I multiply it, has to add up to a negative value. So both values in the parentheses have to be negative. Again, let's just check that to confirm. First, outer, inner, last. Combine your like terms, and you do in fact get negative 60x squared, so that's how we know we're doing it correctly. Okay. Then the last type of problem that we could see in this method is when there's no middle term, when there's no b value. The idea is still the same, okay? in the sense that we just take the square root of the a and the c values. So the square root of 16x squared is just 4x. The square root of 25 is just 5. And because there's no b value, it means that that when we do outer and inner, they have to cancel each other out. They have to add up to 0. And the only way that will happen is if the signs in the parentheses are opposite each other. So again, let's check that. First, outer, inner, last. Positive 20x, negative 20x cancel each other, and so that's how you get 16x squared minus 25. And these types of polynomials are always going to look similar to these 3 examples that we have here, with just different perfect squares. So if I wanted to make another example similar to the ones I have here, I could do 81x to the 10th minus, let's do 49 y squared, okay? Square root of 81x to the 10th is 9x to the 5th, 9x to the 5th. Square root of 49y squared is 7y, 7y. Since there's no b value, one has to be negative, one has to be positive. Okay, so that's the second thing that you want to check for. So first you check for a greatest common factor, then you check to see if a and c are perfect squares. If they're not, we move on to the next method, which is guess and check. This method you only want to use when the a value is 1. You can guess and check when the a value is not 1, but it's not always the most efficient method. So if you look at this first example, here it's just x squared, which means my a value is 1. And here's the idea. You want to think of two numbers. Think of two numbers that multiply to c and at the same time add to b. That's the idea. So if you know how to multiply and add, you know how to factor. So what are two numbers that multiply to negative 8 and add to negative 2? Negative 4 and positive 2. Now let's say you tried positive 4 and negative 2. You get the right number but the wrong sign, so that's when you just swap signs. And so then all I have to do is take those two values, which were negative 4 and positive 2, and that would be the factored form, including the x's. Again, if you don't believe that that's correct, you could just FOIL it to check. All right, next example. Two numbers that multiply to negative 32, but add to 12. Positive 12. The signs do matter. Ooh. Okay, let's see. We know about 8 and 4. One of them is going to have to be negative, though. So that's not going to work because that doesn't add up to positive 12. Okay, 2 and 16. That doesn't work. 1 and 32. Is this even factorable? Doesn't look like it is. So this is actually not factorable. Okay, so then let me come up with another example that is factorable. So let's do x squared minus 8x plus 16. Hopefully you guys recognize that this is a special type of quadratic function that we have seen previously. But if not, take a second and think of two numbers that multiply to 16 but add to negative 8. Okay, those values would be negative 4 and negative 4. So this is actually a perfect square trinomial. Perfect square trinomial means that we could write it also like this. And if you notice, this is actually also factorable using the perfect squares method. Okay, so if a doesn't equal 1, what are you supposed to do? That takes us to the next method. When a doesn't equal 1, you want to use a method which is called splitting the middle, or it's also known as the AC method. The reason it's called the AC method is because you begin by multiplying your a and c values. So you multiply 2 and negative 3 to get negative 6. And it's kind of the same as the previous method, where I now want to think of two numbers that multiply to negative 6, but at the same time add to positive 5. All right, this one isn't that bad. 3 and negative 2 won't work, but 6 and negative 1, that works. So that's my pair of numbers. Now, it's not like I'm just going to take those values and immediately factor it. This is why it's called split the middle, because now I'm going to take this middle term, the 5x, and I'm going to break it apart. I'm going to split it into these two values. So it becomes 6x minus x, and then everything else stays the same. So 2x squared plus 6x minus x minus 3. And now I want to do factor by grouping, where I look at the first two terms, take out their GCF, and then do the same for the last two terms. So the first two terms have 2x in common, with x plus 3 left over. And then the last two terms have a negative 1 in common, with x plus 3 left over. You know you're doing it correctly if the parts in parentheses are the same. And then from there, you create one parentheses with the values that were on the outside, and one parentheses with the values that are on the inside of the parentheses. And then that's the factored form. Okay, let's move on to the final method, which we actually just did. The final method is factor by grouping. This method you use when there are 4 terms in the polynomial. And again, it's very similar to what we just did. You're going to group the first two terms together, group the last two terms together, and take out their GCFs. So in this case, 16 and 6 have a common factor of 2, and then x cubed and x squared have a common factor of x squared. So we're left with 8x minus 3. 8x, negative 8x, and plus 3. Well, see, this is almost identical to that. It's just the wrong signs. So I'm going to factor out a negative 1 to get that. Parts in the parentheses are the same. So it's 2x squared minus 1 times x minus 3. And that's the final answer for that problem. Okay, so now what we want to do is we want to put all of those ideas together and see how we would factor a problem that maybe requires us to use multiple methods, okay? So let's do one where you have to use multiple methods as opposed to just one. Okay, so here. 6x squared minus 45x plus 21. Okay, so here, again, the first thing I want to look for is a GCF. Do these terms have anything in common that I can pull out? And the answer is yes. I could pull out, in this case, a 3. What I'd be left with is 2x squared minus 15x plus 7. Now, at this point, now that you know all the methods, you need to look at the part that's in the parentheses and see if it can be factored further. So this has an a value other than 1, so I have to multiply 2 and 7, which gives me 14. Check to see if there are two numbers that multiply to 14 but add to negative 15. Those values would be negative 14 and negative 1. So now I'm going to do the AC method, the split the middle method. So that's 2x squared minus 14x minus x plus 7. I'm going to do my factor by grouping. I'm going to take out a 2x. I'm going to take out a negative 1. And then create a factor with what they have in common, and another with what's in the parentheses. Okay, another example. I have 5x cubed plus 10x squared minus 7x minus 14. This has 4 terms, so I'm probably going to do factor by grouping, but let's see if there's a GCF first. Is there a term that they all have in common? Nope. So I just go straight to factor by grouping. Group the first 2 terms, the last 2 terms. First 2 terms have 5x squared in common, which means I'm left with x plus 2. Last 2 terms have a negative 7 in common, so x plus 2. Create a factor with the parts on the outside and another with the parts on the inside. Okay. Another example. 8x cubed plus 32x squared minus 8x minus 32. 4 terms. They definitely have a GCF. They all have 8 in common, so I'm factoring that out. So 8 times x cubed plus 4x squared minus x minus 4. Inside the parentheses, there are 4 terms, so I'm going to do factor by grouping. Take out an x squared from the first 2 terms. Take out a negative 1 from the last 2 terms. 1 factor of what they have in common, 1 factor with what's on the outside. And now look at what's in the parentheses. This I can't factor further, but if you look at this, that can be factored further using the perfect squares method, okay? X squared is a perfect squared, and 1 is a perfect square. So what's the square root of x squared? X. What's the square root of 1? 1. Because there's no b value, 1 has to be negative and 1 has to be positive. And then x plus 4 stays as is. I think that's good enough.